bloated on an airplane? Ever wonder why? Hi, my name is Olivia Harmon, and today I will cover that in my talk to you about density. As I was saying earlier, it is very common to feel bloated on an airplane. This is because when you go up into an airplane, the density of the air changes and the pressure changes as well, making the molecules spread, sort of like a balloon. Have you ever tried to put a balloon into an airplane? Let's see what happens. Currently we are at the airport about to board our plane to San Francisco, a 1 hour and 20-minute flight. I will take a picture each minute until we level off, then I will take a picture every 5 minutes. Let's see what happens. This graph demonstrates the measurements we took as the airplane cabin depressurized during ascent. Although the airplane rose to 37,000 feet, the cabin was pressurized to an altitude of 8,000 feet, which is 10.9 here at the 46-minute mark. After that, as the pressurized airplane began to descend, pressure increased much more rapidly as cabin pressure combined with descent into denser air. So what happened? The balloon grew. But why? This is because the air inside the cabin was at 10.9 psi and the air inside the balloon was at 14.7. Since the air inside the balloon was more dense and the air inside the cabin was less dense, the balloon could expand. You can find density practically anywhere, in the air, in the water. An example of air density is why a helium balloon will float while a balloon filled up with air does not. An example of water density is an oil spill. All the oil will float up to the top while the water stays on the bottom because oil is less dense than water. I will demonstrate this by putting an egg in different liquids with different densities. Let's see what happens. Okay, so we're going to drop an egg into waters with different amounts of salt into them. So this is the one with no salt. It sinks. Now we added 1 tablespoon of salt to our water. What happened? We added 1 more tablespoon of salt to our water. So let's see what happens. And as you can see, the egg floated. The reason that the egg floated in salt water but not regular water was because all the liquids had different densities. Water is 1 gram per milliliter dense. Anything more than that will sink. All the liquids had different densities, and for water, the egg was much more dense. Okay, so we have 2 liquids here. The one on the left is rubbing alcohol, and the one on the right is salt water. So we're going to pour these slowly into that cup and see what happens. So there's number 1. There's number 2, and it looks like it's mixing, but as you can see, the top just stood there. It just separated out. Why didn't they mix? This is because they all had different densities, and liquids with different densities cannot mix. Another example of air density is when a vacuum is created. Since there is no density inside a vacuum, and 14.7 psi outside of the vacuum, chances are the thing that holds the vacuum is going to get crushed. I will demonstrate this by boiling water in a can and placing it upturned into freezing cold water. We got a can full of water vapor and freezing cold water, and we're going to condense the water vapor in the freezing cold water, and when we do so, 14.7 psi is going to crush it. So that's the amount of air pressure we live in every single day. So what happened? The can imploded, right? This is because everything filling space inside the can was water vapor. Then, when we put it into the water, it quickly condensed, filling much less space. All of the density on the outside of the can squashed it. I'm done. That's all I have for you this week. Join us next time on Super Science Fun Time with Olivia!